Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And in this video, we will be doing past papers questions for binomial expansion. The first question has been chosen from Winter 2011, paper 1, variant 2, and this is question number 1 in the paper. Part 1, it says find the first three terms in the expansion of 2 minus y to the power 5 in ascending powers of y. Here I should be knowing that I'll have to apply the binomial theorem, for which a minus b to the power n equals a to the power n minus nc1 a to the power n minus 1 b to the power 1 plus nc2 n minus 2 b to the power 2 minus nc3 a to the power n minus 3 and b to the power cube, and so on and on and on. So if we have to do the expansion of 2 minus y to the power 5, then here I should say that this should be 2 to the power 5 minus 5c1, 8, which is a 2 in this case, to the power 4, and it's a y to the power 1 here. For negative y, we have already assigned the coefficient 5c1 with the negative y. We have already adjusted the negative sign, and we know whenever the second term is a negative, we have to have alternate positive, negative, and so on. Then the third term is going to be plus 5c2, 2 to the power 5 minus 2, that shall give me a 3, and a y to the power square. We only have to solve up till the first three terms, therefore I should be stopping here. 2 to the power 5, that gives me a 32, minus 5 times 2 to the power 4, 5c1 is a 5, 2 to the power 4, that should give me a 16y, 5c2 is a 10 times 2 cube, that's an 8, and a y square, and so on. Or I can say that my final answer is 32 minus 80y plus 80y square. So this is going to be the expansion up till the first three terms for 2 minus y to the power 5 here. The second part of the question, it says use the result in part 1. Using the result in part 1 to find the coefficient of x square in the expansion of 2 minus 2x minus x square the whole to power 5. So to the power 5, 2 minus 2x minus x square, and this is whole to power 5 here. So what I can see here is that this y has been replaced by 2x minus x square. So in the expansion in part 1, I should be replacing y with 2x minus x square, meaning I should say it's a 32 minus 80 times 2x minus x square, and then plus 80 times 2x minus x square the whole square. So to get the coefficient of x square, I can see here that it's only if I multiply this 80 by x square, negative 80 by negative x square, and then if I do the expansion here with respect to a minus b the whole square, a minus b the whole square, for which I know that it has to be a square minus 2ab and a plus b square. So let's do the solution first. So this is going to be a 32 minus 80 times 2x, that will give me a negative 160x, and then plus 80x square. And then here I should say it's going to be 80 times 4x square minus 4x cube, and then it should be an x to the power 4 here. So here I can see that only if I multiply this 80 by 4x square, I should be getting the coefficient of x square. So the terms that should interest me is 80x square and a plus 4 times 80x square, or I can say that this is going to be 80x square plus 320 x square, or I can say that the coefficient of x square for this question shall be 400 x square, giving the answer as a 400 over here. Let's do the second question. The second question is from Winter 2013 and paper 1 variant 1, and it's the first question in this paper, where it says find the first three terms in the expansion of 2 plus 3x to the power 6 in ascending powers of x. So let's do the expansion applying the binomial theorem again. And for the binomial theorem, now I should be doing it directly, and I should know that if this is 2 plus 3x to the power 6, then this should be equal to 2 to the power 6 plus 6c1, 2 to the power reduced by 1, giving me a 5 times 3x, plus 6c2 and 2 to the power reduced by 2 from 6, it should be a 4, and then it should be 3x to the power square, and so on. So these are going to be the first three terms in the expansion here. So 2 to the power 6, that would give me a 64 plus 6 times 32 times 3x plus 62, that would give me a 15 into 2 to the power 4, which is a 16 times 9 x squared. So the final answer then is going to be 64 plus 6 times 32 times 3, giving me a 576x, and then plus 9 times 15 times 16. So that will give me a 2160 x squared. So these are going to be the first three terms in ascending powers of x. So this shall be my answer over here. The second part of the question says in the expansion of 1 plus ax times 2 plus 3x to the power 6, the coefficient of x square is 0. So we need to find the value of a. Coefficient of x square is 0, so that means there exists no coefficient as a coefficient of x square. This is what it means when we say that the coefficient of x square needs to be a 0. That means in the expansion there is no coefficient of x square here. So I already have 1 plus ax, and it's 2 plus 3x to the power 6. Therefore, here I should say that it is going to be 1 plus ax times 64 plus 576x plus 2160 x squared. I need the coefficient of x squared. Therefore, I should know that if I multiply 1 by 2160 x squared, I will be getting a coefficient of x squared. Then I should, if I multiply ax by 576x, this will also give me the coefficient of x square here. So here I should say that this is going to be a 2160 x square plus 576 a x square, or it's a 2160 plus 576 a x square. Now, as there is no term in coefficient of x square, the coefficient of x square is a 0. That means it's a 2160 plus 576a. This should be equal to a 0 here. Or solving it, I can say it's a negative 2160 divided by 576, or I can say it's a, which is equals to a 2160 divided by 576, giving me the answer as a negative 15 by 4, and this should be the value of a here. Question 3 is taken from Summer 2012, paper 1, variant 3, and this question says that the first three terms in the expansion of 1 minus 2x the whole square times 1 plus ax to the power 6 in ascending powers of x are 1 minus x plus bx square, and therefore we need to find the values of the constants a and b. So here they have already given us the coefficients. So in this question, they have already given us the expansion for the two brackets, which are 1 minus 2x the whole square times 1 plus ax to the power 6. And here it should be equal to 1 minus x plus bx square. So 1 minus 2x the whole square, applying the quadratic identity for a minus b the whole square, I should say that this is going to be 1 minus 2 times 1 times 2x, that would give me a 4x, plus 2x the whole square, which shall give me a 4x square here. For 1 plus ax to the power 6, I should be applying the binomial expansion, which here should be equal to 1 plus 6c1 ax plus 6c2 ax the whole square, and so on. Or I can say that this is 1 minus 4x plus 4x square times 1 plus 6ax plus 6c2, that would give me 15a square x square. So doing the expansion, just keep in mind that I need the expansion only up till the coefficient of x square, which is a b in this case. 1 times 1, that would give me a 1 plus 6ax plus 15a square x square. I've multiplied the whole bracket. I've multiplied this bracket here with 1, giving me a 1 times 1, that is a 1, 1 times 6ax, which is a 6ax, 1 times 15a square x square, which is a 15a square x square. Then I should be multiplying negative 4x with a 1. So negative 4x with a 1, that should give me a negative 4x plus or minus 4x with 6ax. And then what I can see here is that if I multiply this negative 4x by 15a square x square with x and x square, I shall be getting an x cube, which we do not want in the expansion to find the values of a and b. So here I should be ignoring the third term expansion with negative 4x, and I should just be doing the expansion with negative 4x times 1 and negative 4x times 6ax. Then finally, it should be the expansion with the positive 4x square with 1, that will give me a 4x square. 4x square with 6ax is again x cube, which we do not want, and x square with x square is x to the power 4, which is not required in the question. So I will just limit myself here with the expansion of 4x square times 1, 4x square times 1 here. So plus 4x square times 1, and this shall be the expansion. Let's arrange for the coefficients of x. So this is going to be 1 plus 6a negative 4, and that's it, times x. And then I should be having the coefficients of x square, which I can say are 15a square negative 24a, and then I'm having a positive 4x square here. By comparison, now I should say that initially they have given us the final expansion as 1 minus x plus bx squared. So I should say that I will be comparing it with 1 minus x plus bx square here. Therefore, comparing the coefficients of x, I should say it is a 6a minus 4, which is equals to a negative 1, or it's a 6a which shall be equal to a negative 1 positive 4, or it's going to be a 6a which is equals to 3, or I can say a is equals to a 3 by 6, or in other words, I can say it's equal to a 1 by 2 here. And then comparing the coefficients of x square to find b. This is now going to be a 15a square minus 24a plus 4, which shall be equal to a b. So substituting the value of a, it should be 15 times 1 by 2 the whole square minus 24 times a 1 by 2 and then a plus 4, which shall be equal to b. Or I can say that this is b is equals to 15 by 4 minus a 12 and a positive 4, or it should be equal to a 15 by 4 minus an 8, or I can say that the b value here is going to be a negative 17 by 4. Therefore, my answers are a is equals to 1 by 2 and b is equal to a negative 17 by 4 here. Let's move to the next question. The next question is taken from Summer 2016, Paper 1, Variant 2, and it's question 4th in the paper. And the question says, find the term that is independent of x. It's independent of x in the expansion of part 1, and it says this has to be x minus 2 by x to the power 6. So if we need to have to find a specific term, then we should be knowing that here we should be applying the term formula, and the term formula is Tn, which is equals to Tr plus 1, which shall be equals to Ncr a to the power n minus r and b to the power r. So this is the term formula that I shall be using here to find the term which is independent of x. Another thing to note here is that independent of x means that it is a constant. If I say that this is independent of x, then it's the term which is a constant having a coefficient here, so that x is having the power which is a 0. It's the coefficient or a constant which has x to the power 0 here. So let's apply the term formula to the expansion of x minus 2 by x to the power 6. I do not know the restriction where the term becomes independent of x. Therefore, I will say that my n equals 6. So t n shall be equal to t to the power r plus 1. This is equals to 6cr. A is x, so x shall be equal to 6 minus r, and b is a negative 2 by x, which shall be equal to r here. Let's take all the values on one side and variable on the other, being very particular with the negative sign, which should be having r as the power. And then here I should say this is 6 minus r, x to the power 6 minus r into 1 over x to the power r. Or I can say that this is 6 minus r into x to the power minus r. When the bases are the same, the power gets added. So I should say this is 6 minus r, or x to the power 6 minus 2r. So we have already discussed that for the term independent of x, our x should be having the power as 0. So here I should say that this is 6 minus 2r, which should be equal to x to the power 0, or 6 minus 2r should be equal to a 0 here. Solving it further, I can say it's 6 which equals to r, or then r shall be equal to a 3. Meaning when the restriction is 3, it should be the fourth term, t4, which shall be equal to t3 plus 1. That should be equal to, now I should be applying the restriction, which is a 3, 6c3, negative 2 to the power cube and x to the power 0. So it's going to be 6c3, and 6c3 then shall be equal to a 20 times negative 8, and this then shall be equal to a negative 160. So this is then going to be the answer for this question. Now after solving for the first part, in which we got our T4 which was equal to 106, negative 160. In part 2, they are saying it's 2 plus 3 over x square times x minus 2 by x to the power 6. And now here the expansion shall give me the term which is independent of x. So the term which is independent of x, so we have to do a little bit of critical thinking here. And the critical thinking here is that if we have the constant 2, then it should just be getting multiplied with a constant in the expansion here for x minus 2 by x to the power 6, 2 times a constant, 2 times a constant here. So it's 2 times the constant value. That should give me the term which is independent of x. Obviously, its constant has x to the power 0. With 3x square, I should be having a term. I should be having a term here, Tn, which should be having x square, so that the two x squares with 3 by x square times the term into x square, they should get multiplied, giving us the term which is independent of x here. They two get simplified so that the term becomes independent of x. So this means now I should be finding out the term in x square. Now I should be finding out the term in x square to give us the term which, when multiplied by 3 by x square, gives us a term independent of x again. So I already have the term formula here. We just was Tn, which is equals to Tr plus 1, and that shall be equal to 6Cr negative 2 to the power r and x to the power 6 minus 2r. So I shall be using this term formula again to get the coefficient of x square. So if I need the coefficient of x square, then here I should say that it should be x to the power 6 minus 2r, which should be equal to x square. Now find the restriction. I should say it's 6 minus 2r, which is equals to a 2, or 6 minus 2, that would give me a 4, and this is equals to 2r, or then r shall be equal to a 2 here. So with r as 2, I should know that it's going to be the third term which shall be giving me the coefficient of x square. So for the third term here, I should say it's t3, which shall be equal to t2 plus 1, and that is going to be 6c2 negative 2 to the power of 2 and x to the power of square then. 6c2 then is going to be a 15 times 4x square, or a 60x square. So now I should know that it was 2 times the constant, and we got the constant in the first part, which was a negative 160. So I will be writing 2 times negative 160 plus 3 by x square into 60x square. The x square gets simplified. The x square here gets simplified, and my answer then is going to be a negative 320 and a positive 180, or I can say that it should be a negative 140 as my answer. ये इज़ा क्यों, आफिया क्यों इतना सो रही है यार? Now question 5 is taken from Winter 2013, paper 1, variant 3, and this is question number 8 in this paper. And part 1 of question number 8 says, find the coefficient of x8, coefficient of x to the power 8 in the expansion of x plus 3x square, x plus 3x square to the power 4 here. So I can see that the first term and the second term both are having the variable x, and therefore to get the coefficient of x to the power 8 I shall be using the term formula here. So term formula with n that should be equal to a 4. We know the term formula, it's Tn which is equals to T r plus 1 that equals n C r a to the power n minus r and b to the power r here. So applying this formula, it's Tn which is equals to Tr plus 1. Nth value is a 4, Cr, and a is an x to the power 4 minus r and then 3x square to the power r here. So again, taking all the values on one side as 4cr 3 to the power r and x as a 4 minus r and x to the power 2r, and then I can say that the nth formula is 4cr 3 to the power r x to the power 4 minus r plus 2r, or I can say that this nth formula shall be a 4cr 3 to the power r and x to the power 4 plus r here. So this is the nth formula, nth term formula for the expansion of x plus 3x squared to the power 4 when my n value is a 4, my a is x, and my b is 3x squared. Now we want the coefficient of 8. Therefore, I should say that for coefficient of 8, I should be having x to the power 4 plus r, which should be equal to x to the power 8, or 4 plus r, which shall be equal to 8, and r then shall be equal to 8 minus 4, giving me a 4 here. So r is a 4. Now to get the coefficient of x to the power 8 shall not be difficult. Just substitute r with a 4. So I will be having here 4c4. It is t5 which is equals to t4 plus 1, and this shall be then equal to 4c4 3 to the power 4 and x to the power 8 here. 4c4 is a 1, 3 to the power 4 is an 81, x to the power 8. So it's the fifth term which gives us the coefficient of x to the power 8, and this is then is going to be our answer. Now let's do the second part. The second part says find the coefficient of x to power 8 in the expansion of x plus 3x square to the power 5. The only difference that we see here between part 1 and part 2 is that here they are again asking for the coefficient of x to the power 8. They are asking for the same coefficient x to the power 8, but now the nth value here is different. The nth value here is a 5. That means I should be replacing n by 5 here. So it's x plus 3x squared to the power 5. My nth value is a 5. Again, I will be applying the term formula tr plus 1, which shall be equal to ncr a to the power n minus r and b to the power r. Replacing n by 5, cr, a is an x to the power 5 minus r, and b is then going to be 3x squared to the power of r here. Or solving it further, the nth formula then is going to be 5cr 3 to the power r x to the power 5 minus r into x to the power 2r. Or solving it further, I should say it's tr plus 1, which shall be equal to a 5cr 3 to the power r and x to the power 5 minus r plus 2r. That should just give me a positive r here. So again, I need the coefficient of x to the power 8. Therefore, it's x to the power 5 plus r, which shall be equal to x to the power 8. Or I can equate the powers, the indices. It's 5 plus r, which equals to 8, or r then shall be equal to a 3. So if r is equal to a 3, then that means we are talking about the fourth term in the expansion, which shall be having the coefficient of x to the power 8 here. So 5c3 and 3 to the power cube x to the power 5 plus 3, giving me an 8. 5c3. So T4 shall be equal to 5c3, and 5c3 then is going to be a 10 times 27 x to the power 8, or I can say that the fourth term here is going to be a 270 x to the power 8 here. This then shall be the answer for this coefficient of x to the power 8 in the expansion of x plus 3x square the whole to the power 5. Let's move to the last part. The last part of the question says, hence find the coefficient of x to the power 8. So again, they are asking for the coefficient of x to the power 8. And now the expansion is 1 plus 3x square the whole to the power 5. So we have to be again very much particular and careful about 1 plus x plus 3x square, and this is the whole to power 5. So with n as 5, I should know that if I do the expansion, then the expansion here is going to be 1 plus 5c1 and x plus 3x square. And then it should be a 5c2 x plus 3x square the whole square. And then it should be a 5c3 x plus 3x square the whole square. And then it should be a 5c4 x plus 3x square to the power of 4, and then it should be a 5c5, which is a 1, and x plus 3x square to the power 5 here. Now the reason why I have done the entire expansion here is to make you understand that we have already expanded our terms for x plus 3x square to the power 4 and x plus 3x square to the power 4. That actually gave us the coefficient, which was an 81 x to the power 8. X plus 3x square to the power 4, we already have the coefficient of x to the power 8. X plus 3x square to the power 5 again was solved for the coefficient of x to the power 8, which gave us the answer as 270. Here also we are having x plus 3x square to the power 4, so it's basically connected with part 1, and here this is basically connected with part 2, giving me the answer as 270 here. And for the first part, it was 81x to the power 8. So here I should say that my concern here are the terms for 5c4 into the expansion of x plus 3x square to the power 4, and then it should be x plus 3x square to the power 5. For the rest of the terms, obviously 1 is not giving me the coefficient of x to the power 8. Here the highest power is x square, again x to the power 8 is required, so this is not the required solution here. If I expand x plus 3x squared the whole to the power square, I can see that the highest power is for x to the power 4 here, which is again not required. And here again, if I go for, this needs to be an x cube. So with x cube, I can see that the highest power here is going to be x to the power 6, 2 to the power 2 times 3, that will give me x to the power 6. So the first 4 terms, they were not giving us the coefficient of x to the power 8. So the last 2 terms shall be solved, and we have already solved for x to the power x plus 3x squared to the power 4, giving us the coefficient of x to the power 8. and also x plus 3x squared to the power 5, giving us the coefficient of x to the power 8 here. So let's start solving the solution. 5c4, that is a 5, times x plus 3x squared to the power 4. That answer should be from the first part, x squared plus x plus 3x squared to the power 4 gave us the coefficient of x8 as 81. So I'll just be writing here 81 x to the power 8, and then so now it should be just 5 times 81 x to the power 8 plus 270 x to the power 8 here. So 5 times 81, that should give me 405 plus 270 x to the power 8, and my answer then is going to be a 675 x to the power 8 here. So this is going to be to give us the answer for the coefficient of x to the power 8 for the expansion of 1 plus 3x plus 3x squared and the whole to the power 5. So this is again one question that I wanted to explain to clear the concept of binomial complex expansions here. Let's move to the next question.